Okay, let's finish up on this chapter in this lesson focused on gatekeeper tasks. So a gatekeeper task provides a clean method of implementing mutual exclusion without the risk of priority inversion or deadlock. Okay, so that should catch your attention right away. This is a good technique. We can avoid those issues we just talked about. A gatekeeper task is a task that has sole ownership of the resource. So the idea is you have a resource and you put around that resource a task, and any task that needs to access the resource does so by going through the gatekeeper. So this is a pretty nice way to handle it. Let's look at a gatekeeper example. Suppose you re-implemented this v print string using a gatekeeper task. Well, in that case, when you start up the task, this gatekeeper task is going to manage access to standard out. Right? It's going to manage the output to the shared resource standard out. All the other tasks, when they do a call to print string to send output, what they will do with not knowing it is that inside the implementation of print string, it will send it to a queue, and the queue is read by the gatekeeper. So the gatekeeper simply reads from the queue, and whatever output it gets from the queue, it sends to standard out. Using this technique, then your ISRs can send messages to standard out because they're sending it through the queue. So you actually pick up a bonus on this because the ISR can do one of the queue, send messages to the queue in the ISR, and assuming there's space in the queue, it would go in there, and then we can do prints from an ISR if they're from the gatekeeper class, gatekeeper task. The ISR itself could never do a print string because there's the chance the print string would block. So here's a code demo. Suppose we have a private standard IO gatekeeper task. So just like any other task, right? Doesn't return anything, has one parameter passed in, that's a void pointer. We have our for loop, so we stay in this forever, and all we do is do a queue receive. So this task is doing a queue receive. Previously, before starting up this task, there was a queue set up called print queue. So we just do a receive on that, giving a pointer to where to put the message when it comes in, and we do, in this case, port max delay, because we have nothing to do other than wait for a message to come in on the queue. When it does come in, we do a print, and we do the F flush. And notice we're doing this in a safe manner because all the other tasks, all the other ISRs, they're always sending their print information through this queue. So here, continuing this code demo, we have a print queue variable that we're setting up, and we have a queue handle, of course, that will represent that. So when we come in, first thing we do in our main program is queue create, saying we want 5 slots, and we have a pointer or to tell it how big each slot should be. So in this case, the size of a char pointer, in other words, the size of a pointer, and 5 slots of that. Then we create the task, where we'll create task 1, we'll create task 2, and we'll create our gatekeeper task. Well, the thing is, if task 1 or task 2, if either one of those try to do this print string, now it's going to be handled by this gatekeeper task. And of course, once we have all that set up, we then start the scheduler. So to give a summary, we've looked at how you can do resource management. We've seen how you can have critical sections. We've also seen how you can suspend the scheduler. We looked at the functions for entering critical sections and exiting critical sections. We saw how you could suspend all from the scheduler and also resume. We also saw using mutexes, which we saw they were basically binary semaphores. And then we also looked at using a gatekeeper task, where the task surrounds the resource, and anyone that wants to use that resource will do so by sending things into a queue. I'm Norman McIntyre. Thanks as always for watching.